In our new study, we discuss hygromnemic actuation, which is a new type of actuation in which we force a material to be able to achieve a certain amount of actuation. So in standard hygromorphic actuation, usually the material deforms when it's wet and is straight when it's dry. However, with this type of system, for one humidity, you get one type of actuation. If we want to introduce this type of concept for industrial application, we need more control. And that's what we wanted to achieve with our specimen with a stacking sequence 90-90-90-0 that we condition at high humidity and then dry at 11% relative humidity. But during the conditioning at high humidity, we use a constraining block, which blocks the deformation of the material out of plane in the direction of its deformation. Therefore, when we increase the humidity at the beginning, the 90 degrees layer expands more than the 0 degrees layer, creating out-of-plane deformation. But this out-of-plane deformation is blocked by the constraining block. And therefore, when we dry the specimen at low humidity in the step 4 here, then the 90 degrees layer contracts more than the 0 degrees layer, and therefore you get a deformation out of plane in the other direction than it used to do. Therefore, with hygromnemic actuation, you are able to obtain deformation dry and a flat specimen when it's wet. And with this type of system, we were able to demonstrate the ability of the material to remember the deformation we need. We also conducted some comparison in terms of mechanical properties, showing better mechanical properties for hygromnemic actuation. We also highlighted that this hygromnemic actuation is able to control precisely the deformation that we'll obtain during actuation and introduce much more industrial potential than hygromorphic actuation. Actuation mechanism was demonstrated very precisely with FTAR and DMA, highlighting the influence, for instance, of a glass transition temperature in the mechanism. We also highlighted the reversibility of the hygromnemic actuation, especially related to a window application, which we were able to achieve great control of the degree of opening. So this is a comparison between hygromorphic and hygromnemic. Hygromorphic is on the left, and you can see that when it's wet, the hygromorphic opens. The hygromnemic is on the other side of this window, and it's conditioned exactly the same way. And then the humidity lowers right now, then the hygromnemic opens and the hygromorphic closes, confirming the great potential of control for industrial application, self-actuating windows. So that's the paper we published about it. Please have a look.